Today we are going to discuss about quantum numbers. And what is quantum numbers means? So to describe each electron in an atom, there are different orbitals. We are going to find out where the electron is, and we require three numbers which are commonly known as quantum numbers. And there are four quantum numbers. So the first one is principal quantum number, and it was proposed by the Bohr, and which is denoted with the letter small n, and n value starts from 1 and so on. So the use of principal quantum number is it determines the main energy shell, and it gives the size and energy of an orbit. So it gives the size and energy of the orbit, and as the n value increases, the size and energy also increases. So as n value increases, the electrons are also far away from the nucleus, so which increases the size. And they are shells K, L, M and shells, and n values are 1, 2, 3, 4. As n value increases, the size also increases. And next, second one is the angular momentum. It was proposed by the Sommerfeld and denoted with the letter small l. It determines the angular momentum. So the main use of the angular momentum is determines the angular momentum of an electron. And L value source starts from 0 to n minus 1. Here n is principal quantum number. And next, so when the L value is 0, then the electron belongs to S subshell. When L value equals to 1, then the electron belongs to P subshell. When the L value equals to 2, then it belongs to D subshell. And L equals to 3, then the electron belongs to F subshell. So this is about angular momentum. So by using the angular momentum, you are going to find out the angular momentum of an electron. That's it. And next, third one is the magnetic quantum number. So it was proposed by Landé and denoted with the letter small m. And these values are ranging from minus L passing through to 0 to plus 1. So minus L, m equals to minus L up to 0 and passing through to plus L. So the main use of these magnetic quantum number is it tells us the orientation of the orbits. So we know that the subshells are S, P, D, F, and for S there is one orbit, that is 0, and P there are 3 orbits, values from minus 1 to plus 1, and if D there are 5 orbits which are ranging from minus 2 to plus 2, and for F there are 7 orbits and which are ranging from minus 3 to plus 3. And the last one is spin quantum number. It was proposed by the Goudsmit, and D is represented with the letter S. So the values of the spin quantum number is from minus half to plus half. So the main use of these quantum number is spinning of an electron. So the electron spins in own axis, maybe in clockwise or anti-clockwise, whatever it may be. So clockwise represents plus half and anti-clockwise represents minus half. So this is clockwise, it represents plus half, and this is anti-clockwise, it represents minus half. So the main use of these quantum numbers are, the quantum numbers describes the position. So the principal quantum number describes the position of an electron where it is in the main shell, and if it is a subshell, then by using the angular momentum quantum number, we are going to find out the subshell. And the orientation of the electron gives us magnetic quantum number. And the direction of spinning, the direction of the electron, which tells us by spin quantum number. So by using these four, we have to find out by using these quantum numbers, we are going to describe an electron, in which the electron at different orbitals.